we'll pick up this lecture with isomers. So the other day in class, we talked about cis and trans isomers, but there's also a wide variety of other isomers. So the next section that we're going to look at is titled Isomers. And typically what happens in terms of the progression of science is where one type of a theory is developed, and then we can try to apply that to other things. So in this case, we had been shown that cis and trans isomers exist. And now the question is, are there any other types of isomers that could potentially exist? And there are. So if we categorize or group all of the coordination compounds or coordination complexes, we can put the isomers into different subgroups. So if we have all coordination complexes, there are two main groupings that we can put for isomers. The first are structural isomers. And in a structural isomer, the bonds to the transition metal are different. The other subgrouping of isomers that we can group is stereoisomers. And in stereoisomers, we have identical bonds to the transition metal center. I use transition metal center here, but in reality, we can use any type of central metal or central atom. Organic chemistry, you're going to study these isomers in much more detail with carbon-based complexes, okay? And in that case, the bonds to the carbon would either be different or identical. So if we looked into the subcategories then of structural isomers, there are two types of isomers that we're going to talk about in our textbook. Those types of isomers are called linkage isomers. And the other category is coordination sphere. So linkage isomers will have subgroup number 1, coordination sphere group number 2. We can also look at the different stereoisomers, which have identical bonds to the transition metal center, and we can put them into two other categories. The first is geometric, and the second is optical. So this would be group 3 and group 4. So there's 4 different isomers that we are going to discuss in this class, and I expect you to know and to be able to identify each one of these 4 given a coordination complex. Okay? And this chart right here, if you read section 24.4 or page 1026 of our textbook, you make sure you want to look over that.